Well, let's make this as short and painless and simple as possible to do some electronic review. Now, you can never know too much about the subject, but I have a problem with the Ohm's Law pie chart that I'm seeing right here. As a matter of fact, this isn't the worst one I've seen. The worst one I've seen has the E equals I times R. Last time I checked, my multimeter doesn't have an E or an I on it. It's got a V for volts, and it has a horseshoe symbol, the Greek letter omega for ohms, and of course, A for amps, or MA for milliamps. So let's keep it simple and just talk about it from a short perspective here, and that's the relationship between voltage, which is like the pressure in that cartoon there, pushing the volume of electrons through the circuit, and the resistance is that restriction to the flow of that current measured in amps or amperes. So the relationship between those three items is always what we need to know and just remind ourselves and review over and over until it becomes like, you know it like the back of your hand, so that when we do voltage drop testing, both on live circuits and in the case of the parasitic current draw, voltage drop testing across the fuse, which we're going to do later, makes all the sense in the world. So it's the relationships we're going to talk about here as we look at this familiar chart, voltage equals amps times ohms. Now, as you make the amperage go up, it's because the ohms triggered it. The ohms went down. The resistance goes down, and that causes the amperage, the current draw, to go up if voltage remains the constant. And conversely, if we have the ohms go up, the resistance in a circuit go up, the current draw is going to go down if voltage is consistent. Also, this same chart, keep in mind that if you don't know what one of the factors are, there's just three things, right? Volts, amps, and ohms. If you don't know what one is, but you know the other two, you can simply do a multiplication or division problem like so. If you know the battery voltage is 12 and you know the resistance of an injector is 6 ohms in this case, you know it's going to draw 2 amps of current. So we just do the math. 12 divided by 6 equals 2. And the same way, if you know what the resistance is across some resistor in a circuit, either be a resistor it's supposed to be there, or a resistance that's inadvertently in the circuit, a rusty or corroded connection. You know what the resistance is, and you know what the current is. Let's say the resistance is 6 ohms and the current is 2 amps. You know what the voltage drop will be across this particular point, this resistance. And that's what we were doing earlier when we talked about our shunt circuit and doing the voltage drop across the shunt circuit to determine what the current draw in milliamps would be on that vehicle. And of course, we know it's going to be 12 volts if we have 2 ohms or 6 ohms of resistance and 2 amps of current in the circuit. So that's in essence a real quick summary of Ohm's law. Now, if you really want to plug some numbers in, it really brings the whole concept of the relationships of ohms, amps, and volts to light. And this is kind of cool. You just go Google an Ohm's law calculator, and you'll find something that looks like this. If we plug in some numbers here, we know the voltage in a series circuit is 12.7 volts. And the current draw, or the resistance I should say, is 0.1. So way less than 1 ohm, a tenth of 1 ohm of resistance total in a circuit leading up to a battery. What's the current flow out of that battery going to be if you have 0.1 amps? Now that's a pretty low resistance. What would you guess? It's going to be a high amount of current, showing 127. So you plug in 2 numbers, you get the third automatically in one of these Ohm's law calculators that's online.